Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
My dear wonderful students of Senior 3, I just want to welcome you to this lesson number 7 of Unit 8, which is Electrolysis and its application. That is Unit 8, and this is lesson number 7. Lesson number 7 will be looking at the applications of electrolysis. And probably we'll have one more lesson on demonstrations of these electrolysis, but this was supposed to be the last lesson. So I would want you to pay attention. Be ready, please. Have your notebook and pen so that as we move along, as I write some of the reactions that are taking place, please be ready and you write down some few notes. You'll not be able to write everything that will be on the screen. Please, this is the concept. When we talk about electroplating, what does it mean? Electroplating. It is just very simple. Electroplating is coating a metal, covering a metal with another metal using electrolysis. But it can also be a plastic coated with a metal. It is also possible. So this is the process. We'll just have a look at the screen over there, and then you define. Process where the surface of one metal is coated with a layer of a different metal. Of course, that layer will be very thin. You don't coat it with a lot of another metal with it. We're just going to look at the reasons why we have the electroplating is carried out in everyday life. So the metal being used to coat, so this is the concept. So for the electroplating to take place, you need some concepts that you need to carry, and this is very important. Dear students, please take note of this. So the metal being coated, or used to coat, I beg your pardon, is a less reactive metal than the one that is covering. We looked at the electroplating. Well, we looked at the reactivity series. A metal being used to coat, maybe that metal that is used to cover another metal, must be less reactive than the one that it is covering. That is very important to note. 2, anode is made from the pure metal used to coat. So that metal that you want to coat, that metal that you are going to use for coating, must be connected to the positive terminal and must be a pure metal. If you are going to coat, for example, let me just give an example. If you are going to coat copper to another metal, that copper must be pure. That is what it means. And it has to be connected to the anode. That is point number 2, which is very important. Number 3, the cathode is the object to be electroplated. So once the metal used for coating is the anode, then the other metal that is going to be coated or electroplated must be the cathode on the other hand. That is almost like opposite. One for coating must be anode. The one to be coated must be cathode. I think it makes sense there. Please take note of that because these are very important information that you need to carry on. The electrolyte, this is another fourth point that you need to remember as far as electroplating is concerned. The electrolyte is an aqueous solution of a soluble salt of the pure metal at the anode. We said anode is made from the pure metal used to coat. That metal used to coat must be anode, and it has to be pure. Then the solution, the electrolyte that you need to use, the solution, that is the electrolyte, it must be the solution of that metal that you are going to use for coating or for electroplating. Please take note of those concepts, very important as far as electroplating is concerned. So let's look at let's go to the next slide and look at the electroplating tin metal. That means the tin metal is the one that is going to be coated. So the electrolyte here, as we first start, you start with the electrodes. We said that the metal to be coated must be cathode. Cathode is the negative electrode over there. So this is cathode. So that means that metal, this is the cathode, that it is connected to the negative terminal. That is where the tin will be coating. So that metal, so that actually it is a strip of iron metal. So the tin will be covering it. So we can see the tin covering this. Look at the screen over there. And this is anode. This must be tin, and it has to be pure tin, as we said. The anode, the metal that is used for coating, must be pure and connected to the anode, positive terminal. The electrolyte must be the solution of the anode that you are going to use. If you are going to coat the electrode here with tin, then the anode must be pure tin and a solution of tin. For example, here we have tin 2 chloride. Not only that, we can have tin 2 nitrate. That is also a soluble solution. Tin 2 nitrate, you can have even tin sulfate is also soluble. So you can have those solutions of the solution. What is taking place? I just want you to take note of this. The reactions at the anode, reactions at the electrodes, reactions at the electrodes. So that is what we are going to look at, and we will start with the anode. So what takes place at the anode? Anode, look here please. The anode is made up of tin, and the cathode is made up of iron. It is going to be coated with tin. So where is this tin coming from that is going to coat this? It is coming from this strip of pure tin and the tin 2 chloride, the solution. So you have the anode, which is tin metal. It is a solid form. Remember the concept that we talked about of the nature of the electrode when the electrodes are similar. When the electrodes are similar, the nature of the electrodes, we talked about it in the previous lesson. When the electrodes are similar, the anode inserted into its solution starts dissolving. So it undergoes what we call oxidation. As usual, oxidation takes place at the anode. So we'll have tin now dissolving or oxidizing to form tin 2 chloride, tin solutions with electrons being lost. So this is the reaction that is taking place at the anode. At the cathode, what takes place? Because we have seen that at the cathode, there is a deposition of the tin. So these ions which are formed in the solution of the tin 2 chloride, the tin 2 ions, there are some in the solution and others are coming from the electrode. So these tin electrode, the ions of tin 2 will move to the cathode. And once they reach at the cathode, they will gain the electrons. You remember at the cathode, there is what we call reduction. Reduction takes place at the cathode, whereas oxidation takes place at the anode. So here we have, this one will change into the tin, which is the metal. So there will be deposition of the tin metal. Some of you who put on some watches, if you are very rich, you'll buy a watch that is coated with gold. A thin layer, because the more the metal coating, the more expensive it becomes. We have substances either coated by silver. Look at the coins. When I talk about the money coins, everybody understands money. Look at the 50 coin. It is coated with silver. It shines. How do they coat that metal with silver? Look at the copper. Copper has silver and it has another metal, and it has the copper inside. I don't know whether I have some coins here. Let me check and I show you these coins. Yes, perfect. I have some, fortunately I have them here. So I'm just going to show you these coins. Look at this, this is a 50 coin. This 50 coin is coated with silver. And the process that is used is this electroplating that we are talking about. Electroplating, covering a metal with another metal using electrolysis. Look at this 100 coin. When you look inside, the outer part, this covering outer part is silver. But the inside part, where there is 100 written, 100 flanks, you see the brown color. What is that brown color? That is copper. So this is the coating of the metal with another. This is done with other substances as well, the watches, the necklaces, in general jewelry. So that one, it is also done. Even some machines. When you look at this when you look at the laptop, there is some silver covering. When you look at the cover here, over here, there is some silver covering. And how do they do this? It is with their electroplating. So electroplating is commonly used in industry for such purposes. So let's move on. Why electroplate? There are so many uses. One of the uses of electroplating is done to make metals more resistant to corrosion or damage. Corrosion or damage. Either we can talk about chromium or nickel plating. These are other metals. Or copper. Copper does not easily rust. It cannot be easily damaged. And these metals that are used for coating, in most cases, they are less reactive. Less reactive. When you throw this copper coin that I had, or rather the coin of the money, and you throw it somewhere, you can even pick it when it is still valid with the metal coated there because of its less reactivity. It doesn't react with water. It doesn't corrode. It cannot be easily damaged. And that's why they use metals that are less reactive for coating. It is also done to improve the appearance of the metals. Of course, a metal that is coated will appear differently than the metal which is not coated. I've just mentioned about silver coating. I've mentioned about the gold coating for necklaces. That is for appearance. So appearance does what? Increases the price of the commodity. The necklace which is covered with zinc is not the same in the market. You will not buy it the same amount of money with that one that is covered with gold, because they have different amount. They are valued differently in terms of money. Gold is more expensive than the silver, or it may be expensive than the zinc. So that appearance can also increase the economic status. Silver plating, like cutlery, when you look at for example, the utensils, most of the cutlery they use in the kitchen, the knives, the spoons, the forks, and all those stuff, you'll find that they are being coated with either nickel or chromium or any other substances for less corrosion. If they are not corroded, if they are not covered, then they will rust easily. So I've just included this website. Please, you can take it and then look at the more uses. There are so many of them. I've not mentioned all of them, but I've just tried to give you this, this link so that it takes you there and look at the information that you may need. Just a few seconds, copy it, and then it has been there. I hope you have already copied it. So that is the link that will tell you, that will take you to other uses of the electroplating. So let's look at another use. So we are talking about electroplating, and then what is this electrolysis? One of them we have mentioned here, we are mentioning about the electroplating. Electroplating as one of the uses in daily life for electrolysis. And another one that we're going to look at is purification of metals. Purification of metals. So, but we have given an example of the copper. Purified, refining. That means during the extraction of copper, copper is not extracted in its purest form. It has some other ingredients, other components with it, especially the oxides. Copper is very useful as far as the wiring, the electricity is concerned. In very many electrical appliances, copper is used. We have even seen that even copper is used in covering the coin, so it is very important. So it has to be in its purest form. So how does purification take place? How does purification take place? This is the purification of copper. So these are the key factors. Remember what we talked about. So we have, this is the diagram. We have the cathode, we have the anode. So the anode has been eaten away. So the anode here, copper eaten away from the anode. So that, what does this mean? That this anode must be impure copper. I've written some key points that you need to remember down. So this is the cathode. When you look at the cathode, the size of the cathode here is increasing. It is becoming bigger. So meaning copper is being deposited there. As we said, electroplating. So the electroplating is almost done similarly like as purification. So these are the key factors. Remember I said the electrolyte here also must be made of the solution. So when you look at the electroplating, it is also similar. It has some similarity with electroplating. Why? Because we have the copper in here, but the only difference is that the anode this time has to be impure. So let's look at the key factors we go through together. The electrolyte is an aqueous solution of copper 2 sulfate, not only copper 2 sulfate. It must be a solution that also contains copper 2 ions. Copper 2 ions. So we have copper 2 sulfate, that is one electrolyte. So we can have copper nitrate, copper 2 chloride, and so on. As long as you have a soluble solution that contains copper 2 ions. The cathode has to be pure. You remember in the electroplating, I need you to take the note. In the electroplating, the cathode is the one the anode is the one which was pure. And in this case, in the purification, the cathode is the pure one, whereas the anode is impure. So that means they are opposite. This electroplating is the opposite of purification. Copper dissolves from the anode and deposited, as we mentioned earlier. It is the same thing that is happening in electroplating, and when you have this, it is also, when you have the purification, it is also the same. Impurities such as silver are deposited on the bottom of the cell as a sludge. So when you look at this diagram, you see the sludge. So those are some impurities. removed from here within the anode. This because this is impure copper. So we can move on the extraction of aluminum. Most of the iron sheets, most of the materials, these electrical transmission cables, the high-grid transmission cables are made of aluminum. The boards of the aircraft, they are made of aluminum. The roofings, most of the roofings are made of aluminum. In most cases, many usually say iron sheets, but they are not all sheets are made of iron. Many of them actually they are made of aluminum. Many of them are aluminum. So in the extraction of aluminum, I'm just mentioning aluminum as very important, and that is why we are mentioning extraction. This was number 3, so we have extraction of aluminum. So in this case, aluminum is extracted from the oxide called bauxite. The bauxite is aluminum oxide, which is hydrated. It is mixed with cryolite because aluminum oxide has a very high boiling point. So it is mixed with cryolite. Cryolite is aluminum hexafluoride. That is cryolite. So it reduces the boiling point of the melting point of aluminum, and 2, it produces ions for conductivity. So aluminum oxide conducts better. The electrolyte is kept at high temperatures so that all of aluminum oxide remains in the molten form. So that is the diagram. The diagram, you have graphite, which is made of anode, and then you have graphite, which is cathode. It is making up the lining of this diaphragm cell. And then you have aluminum moving out. So the aluminum ions here will be moving to, we have the oxygen moving to the cathode, to the anode, and then you have aluminum ions which will go to the cathode and then deposit as aluminum metal. So this aluminum oxide must be pure and mixed with molten aluminum or with this cryolite, which we said its purpose is to reduce the melting point as well as increase the conductivity of the electrolysis. So you need to take note of that. So some important information during the aluminum. We have mentioned this bauxite as the raw material. Now, at the negative electrode, you have the aluminum ions accepting electrons. So these are aluminum ions coming from aluminum oxide. So you have the oxide ions at the positive anode changing into oxygen. Remember, oxygen is produced at the anode, and the anode is made up of carbon. Therefore, the anodes have to be repressed from time to time. Why? Because the carbon reacts with oxygen. The carbon, this is the cathode now, or rather the anode, which is made up of the anode. So it reacts with oxygen to produce carbon dioxide. So that is why the anode has to be repressed from time to time as the electrolysis process goes on. Another point that we need to mention is manufacture of different gases. Chlorine, we have chlorine, hydrogen, and sodium hydroxide. Sodium hydroxide is used for making detergents. So we don't manufacture sodium. We make soap, and one of the raw materials for soap is sodium hydroxide. And we don't have this sodium hydroxide. So the sodium hydroxide is imported. It is a raw material. It is imported from outside to make the soap. So this is the diaphragm that is used in the production of these gases. So you have the chlorine being produced, and then you have hydrogen produced, But again, you have dilute sodium hydroxide moving out. So there are three important products: chlorine, hydrogen gas, and sodium hydroxide. And this is the diagram. So the here, brine is the electrolyte. That is concentrated solution of sodium chloride is used as an electrolyte. So this is the cathode. You need to remember, the cathode is made up of steel, and the anode is made up of titanium. So these are different metals. The electrolyte is made up of brine, which is a concentrated solution of sodium chloride. So these are the factors, these are key important parts that you need to remember about the manufacture of chlorine, hydrogen, and sodium hydroxide. So you have the anode usually made of titanium, we have seen that. The cathode is made of steel, and the electrolyte, we have also mentioned a solution of sodium chloride, which is concentrated. Chlorine gas is produced at the anode because it is negative, so it has to go to the negative terminal. The hydrogen gas is produced at the cathode, so the hydrogen ions, because it is contains some water, so the hydrogen ions will be discharged. And therefore, this is the reactions that are taking place. Those are the two reactions which are taking place. And eventually, the hydroxide ions produced here, because water will be reduced. If water is reduced, so you have the reduction of water gaining 2 electrons to produce the hydrogen gas plus the OH ions. And these are 2 OH ions. So what does that mean? When the hydrogen is produced as a gas, what is remaining behind is the OH ions. So the OH ions will combine with the sodium ions, because the sodium ions are not discharged. So we are not seeing sodium discharging. So the sodium ions will combine with the OH ions in the solution, and this one is equivalent to sodium hydroxide, which is a very important raw material as far as manufacturing of soaps and detergents are very important. Thank you so much for being there with me. I hope I will see you in the next lesson and you'll be there. Please stay safe and have a good day. Bye-bye.